In October 2017, a disclosure stunned the scientific world and sparked a rush of speculation and excitement. The Pan-STARRS Observatory in Hawaii captured something extraordinary, an object speeding through our solar system from outside it. Named Oumuamua, meaning scout or messenger in Hawaiian, this object was more than just an interstellar visitor. It was the first of its kind ever identified, challenging scientists' understanding of space and raising questions we have barely begun to answer. What set Oumuamua apart from any other celestial body we had encountered was its extraordinary shape, behavior, and origin. Conventional objects from our solar system, such as comets, asteroids, and meteors, have predictable structures and characteristics. But Oumuamua wasn't like anything we had seen before. Its elongated, cigar-like shape, rapid speed, and unusual trajectory immediately drew attention. As scientists scrambled to collect data during its brief appearance in our solar system, they realized this object held secrets that could transform our understanding of the universe. With telescopes worldwide trained on this unusual visitor, astronomers had only a few short weeks to study Oumuamua before it disappeared into the depths of space. The questions surrounding it grew with every new observation. Why did it accelerate unexpectedly as it moved away from the sun? Why didn't it have the tail or coma typically associated with comets? Could it be a natural object, or was there a chance, however small, that it was artificial, perhaps even a probe from another civilization? As we continue to seek answers, Oumuamua remains a fascinating mystery, a reminder of how little we truly know about the universe. Section 1. What makes Oumuamua unique? When Oumuamua was first spotted, astronomers quickly noted its exceptionally unusual shape. Based on limited observations, scientists estimated it to be at least 800 to 1,000 meters long, possibly stretching up to a kilometer. However, its width was much smaller, with estimates suggesting a 10-to-1 ratio, meaning it was significantly longer than it was wide. In the realm of known space objects, this shape is virtually unprecedented, as most asteroids and comets exhibit more spherical or irregular forms. This slender, elongated shape led to much speculation. Was it a shard of a larger object that had broken apart? Or could it be some form of alien technology, perhaps a solar sail? Its rotation added another layer to the mystery. Observations showed that Oumuamua was tumbling through space, not spinning in a smooth or predictable manner. This erratic tumbling caused rapid changes in its brightness, as different parts of the object reflected sunlight at varying angles. The way Oumuamua flashed, almost like a cosmic beacon, led scientists to believe it might have an unusual surface composition or texture. Some speculated that its shape and spin could result from a catastrophic event that ejected it from its home system millions, or even billions of years ago. Section 2. Theories on Oumuamua's origin. As scientists pondered Oumuamua, theories about its origin multiplied. One of the primary ideas was that it could be a fragment of a larger body, possibly a planet or moon, that had been shattered by a massive collision. If such a body were ejected from its home system, it could travel through interstellar space for eons, shaped by impacts and gravitational interactions along the way. Another compelling theory was that Oumuamua was a type of interstellar comet. However, it defied traditional definitions of a comet, which are typically characterized by the emission of gas and dust when passing near the sun, forming a visible tail. No such outgassing was detected around Oumuamua, ruling out typical comet behavior. Some scientists hypothesized that it might be composed of unusual materials, such as nitrogen ice or even hydrogen ice, which could sublimate without leaving a visible trail. However, these materials are rare and would need to survive a harrowing journey through interstellar space, making this hypothesis less likely. One of the most remarkable theories came from Harvard astrophysicist Avi Loeb, who suggested that Oumuamua might be an alien probe or a piece of advanced technology. Loeb proposed that its shape, acceleration, and lack of a conventional tail could indicate that it was a solar sail, a lightweight, highly reflective structure propelled by sunlight. If true, this would suggest that Oumuamua was intentionally sent to explore, possibly by a distant civilization. While controversial, Loeb's hypothesis added a provocative dimension to the debate and highlighted the limits of our current understanding of interstellar objects. Section 3. Tracking the mysterious trajectory. Oumuamua's path through our solar system was as unusual as its shape. Unlike most objects entering our solar system, Oumuamua came from above the ecliptic plane, the flat, disc-shaped region where most planets and objects orbit. This unique approach meant it interacted with no major planetary bodies, leaving scientists puzzled about how and why it took this route. Even stranger was how Oumuamua accelerated as it moved away from the sun. This unexpected acceleration defied explanations tied to gravity alone. While comets can sometimes accelerate when their ice sublimates and produces jets of gas, no such jets were detected around Oumuamua to account for this. Some experts suggested that the object might have unknown physical properties or a unique composition, such as solid hydrogen or nitrogen ice. Alternatively, it might even have elements we don't yet understand, hinting at possibilities beyond natural explanations. Scientists used the Gaia spacecraft to try to trace Oumuamua's origin, but the results were inconclusive. Its trajectory suggested it could have come from the direction of the Lyra constellation, but without a clear starting point, its true origins remain a mystery. Section 4. Scientific Perspectives and the Debate over Alien Technology. The possibility that Oumuamua could be alien technology divided scientists. Avi Loeb's controversial stance suggested that if we don't consider alien technology, we might miss evidence that could transform our understanding of the universe. According to Loeb, the object's high reflectivity and unusual acceleration could indicate artificial construction, like a solar sail designed to travel through space using radiation from stars. Other scientists, however, argued for caution, emphasizing that extraordinary claims require extraordinary evidence. The current data on Oumuamua does not conclusively support the alien technology hypothesis. These experts suggested that Oumuamua's strange characteristics might result from factors we don't yet fully understand about interstellar objects, such as unknown forces or compositions. This debate also highlights a philosophical aspect of scientific exploration. Should scientists remain open to hypotheses as extraordinary as alien technology, even with limited evidence, or should the burden of proof be so high that such theories are dismissed without rigorous evidence? This discussion reveals the limits of our knowledge and humanity's tendency to question everything we observe in the universe. Section 5. Limitations in observation and the race against time. The fleeting nature of Oumuamua's visit presented unique challenges. By the time it was discovered, it was already on its way out of the solar system, leaving astronomers with only a few weeks to gather as much data as possible. Current technology allowed for some observational opportunities, but limited resolution prevented detailed imaging. As a result, scientists had to rely on indirect observations, such as brightness fluctuations, to infer its shape and behavior. If Oumuamua had been detected earlier, more extensive studies could have been conducted, potentially revealing more about its composition and structure. This experience has underscored the need for advancements in our ability to detect and study interstellar objects. Future missions, such as the European Space Agency's Comet Interceptor, are designed to wait for objects like Oumuamua and intercept them, addressing this issue in observational capabilities. Section 6. Proposed future missions and the role of Project Lyra. Project Lyra emerged as a proposed mission to intercept Oumuamua, despite its rapid departure from the solar system. Such a mission would require an extraordinarily fast spacecraft capable of traveling over 20 kilometers per second to catch up with the object, potentially using gravity assist from planets like Jupiter or Venus to boost its speed. However, reaching Oumuamua would still take decades, requiring meticulous planning and substantial resources. This mission could cost billions, raising questions about the feasibility of sending a spacecraft after a single object. Yet, if Oumuamua holds secrets about alien technology or interstellar origins, the potential scientific payoff could be monumental. Project Lyra's ambitions reflect humanity's deep curiosity and willingness to pursue answers despite the challenges. Section 7. Comparing Oumuamua with other interstellar objects. Since Oumuamua's discovery, another interstellar visitor, Comet 2I/Borisov, has been observed, providing a valuable point of comparison. Unlike Oumuamua, Borisov displayed typical cometary characteristics, including a visible tail and gas emissions. Studying Borisov has helped scientists understand what a more conventional interstellar object might look like, while highlighting Oumuamua's unique nature. This comparison suggests that interstellar objects may come in a broader variety of forms than previously imagined. While Borisov conforms to our expectations, Oumuamua's peculiarities, its shape, lack of outgassing, and unexpected acceleration, remain unmatched, continuing to puzzle scientists and inspire further research. Section 8. The ongoing mystery of Oumuamua. Oumuamua represents a turning point in our understanding of interstellar space. Its discovery has not only expanded our awareness of what might exist beyond our solar system, but has also revealed the limitations of our current technology and theories. Whether natural or artificial, Oumuamua challenges us to think beyond conventional explanations and to prepare for future encounters with interstellar visitors. As technology advances and new missions are developed, scientists hope to uncover more about objects like Oumuamua. Each discovery brings us closer to answering profound questions about the universe. Are we alone? What forces shape these mysterious travelers? And what secrets do they hold about the origins of life and the cosmos itself? For now, Oumuamua remains a tantalizing enigma, a cosmic messenger that has left us with more questions than answers, urging us to continue exploring the vast and uncharted depths of space.